Up to this point in the class, we've generally been executing one command at a time by typing the command at the prompt, pressing the enter key, and waiting for the results to be displayed to the screen. So if we wanted to see a long listing of files in the root, we'd type ls-l /. We made that process a little more complicated with the introduction of piping and redirection. So we can combine two commands together like this, but the basic process was still the same. This week we're going to look at a way to accomplish some more complex tasks using shell programming. The basic idea behind shell programming is that we'll write a series of commands in a text file that will later be executed in sequence. We can put as many commands as we want into that file, and we'll also introduce a way to store the results of a command for later use. This will allow us to accomplish tasks that would be unwieldy to execute directly at the prompt, and automate repetitive sequences of commands. Shell program can even be used as a full-fledged programming language, though we won't go that far in this class. In this video, we're going to write a shell script called journal that will allow us to add dated journal entries into a file on the system. When we execute the journal shell program, it will prompt us for a title and content for our journal entry and automatically write them both into a file along with the current date and time. We'll create that file as we've created other text files up to this point, using Vim. So I've opened up this file in Vim, just typing Vim journal. And the first line I'm going to add to this file is the number sign, which is the Shift-3 on your keyboard, exclamation point, /bin/bash. The number sign exclamation point is a combination we'll call hash bang. So the hash symbol being the number song, a bang being an exclamation point. This line will tell the operating system to interpret the commands that we're going to write in this file using the bash shell. That's the shell we've been using all along. When we log into Mercury, the bash shell is the default shell that we use. Pages 276 and 277 in your book describe some of the other shells that are available on Linux systems. This line isn't strictly necessary for the shell script we're going to write, but it's a good habit to include it whenever you're going to write a shell program. Next, we're going to add a few comments at the beginning of our file. Comments are lines in the program that are written for the programmer but will not be executed by the computer. They start with that hash symbol and can contain any text that you want. I'm going to add comment lines to describe what this program is going to do and make note of the author and inspiration for this particular file. The next line I'm going to add in the file, it will create a variable that will store the path of the output file, so the journal file that we're going to create. Variables are an important part of shell program. They allow us to store values for later use. So it's going to look like this. And actually this should have been all caps. So file equals $home in all capital letters /journal-file. To create a variable in bash, the variable name goes on the left hand of an equal sign and the value goes on the right hand side. There are no spaces allowed between the name, the equal sign, and the value. In this case, a variable named file is set to a file named journal-file that's going to be in the user's home directory. The $home that appears there as part of the path is the reference to an environment variable that will store the full path to your home directory or whatever user is running the script. Next, we're going to add the current date into the file so that our journal entries always have a date at the top. So we're going to use the date command, which would be type it just as we would type it on the command line. And then we're going to redirect that using the $, the double greater than, into $file. So we've looked at this append redirect before, and so that's what that double greater than is. It's just going to append it into a file, And the file that it's going to append it to is going to be the one that's indicated by our file environment variable. The $file refers to that variable we created earlier. In Bash, we precede a variable name with a $sign to refer to its value. Next, we're going to output a message asking for a title to the screen. We can use the echo command for this. It's a command that simply displays whatever text follows it to the screen. And I'm going to use it with the -n parameter, which just tells it not to put a new line at the end of the echo statement. Next, we're going to get the title from the user. To do this, we can use the read command. So this is another way to create a value in a variable. Title is a variable name. The read command will get that input from the user and then store it in that variable. Then we're going to take the value of the variable that they just entered and put it into our file. So echo, in quotation marks, $title, double greater than, into $file. The reason we put the quotation marks around the variable title is that it prevents it from having our command from having problems if the title had a space in it. So that helps with that. Now we're going to add a blank line to the file to make it easier to read later on. And now we'll prompt the user to enter their message text. Notice that we're giving the user enough feedback that they know what they need to do, so they're not confused as they're using the file. We can get this sort of multi-line text input using the cat command. We've used the cat command to display files to the screen, but when it's used without parameters, it will get input from the keyboard, which can then be redirected to a file. So cat space double greater than space $file. Now we're going to output a line of dashes that will separate this entry from the next one. And we're again going to send that using that double redirect into our file. It's not important that the number of dashes matches with the number of dashes that I typed in. And finally, we're going to output another blank line at the end of our file. Take a look at this finished file and correct any errors that you might find, any differences between yours and mine. And notice the capitalization and spacing might be important when you're working with this. So I'm going to save the script file and exit back to the command prompt. I'm going to clear the screen here. And now before we can execute our command prompt, we need to make it executable using the chmod command that we've used before. So chmod u plus x of journal was the name of the file. And now that we have made it executable, we can execute it by typing // and the name of that file. So /journal. It's going to ask me enter the title for this entry. I typed in CIS 220 video creation, enter the text of your journal entry. This is a sample journal entry. It has words, but not meaning. And then I'm going to press Control D here. And now our script has in fact executed. So if we do use the ls command now, we'll see that there is a file called journal-file. If I look at the contents of that file, then you'll see it has the current date and time, along with the title on its own line, and then it has my journal entry that I made, along with a line of dashes. So we could run our script again, make a second entry, again, I hit Control D when I'm done. If I look in that journal file again, now I see that it has 2 entries. Each one of them has the date and time that it was created, and they are separated by that line of dashes. The big takeaway from this is that you can combine commands together in a script file to do things that you can't really do with individual commands on the command line. The possibilities of what you can do are nearly unlimited once you get going. I hope that you enjoyed this video.